about the homework, then we will blaze on.
No,
Seriously, how do we
it's
do
so
it?
confusing.
What, I didn't understand the last question. That was the only one I didn't get.
Alright, where's the, we got the homework piece.
Here, I have it.
I have it somewhere.
Oh, I got all the answers. Just the answers.
That's probably what's the answer.
I checked all
The last one.
Here already.
No, I there was most of it.
That's the FE question, FEAGN03. Okay. Let's take a look at it. Alright, so we have, wow, look how dark it is. FEAGN03 goes to FEN03 2
Oh,
plus AG. This is incidentally the way you recover silver from silver nitrate.
I can't see anything, Dad.
Oh, I'm sorry, camera. All right. So, first of all, what kind of reaction is this?
Wait.
Single.
Yeah.
Yep, single replacement. So it's a single replacement. Single replacement. Really? The AC's coming on? It's like freezing out here.
Why you couldn't turn it
We
on?
could just turn it off.
It's pretty much the average.
All right. So, what was the question? What did it want us to do? Also, have the answer.
You sit on the chair and block the camera. And now that I moved the chair, you're still going to stand there and block the camera.
What was the question? I don't have the questions.
I don't know. You're holding.
Looks like something about 100 grams.
How many
of silver.
grams of Fe will need to react with that amount of AgNO3 to make that amount of silver?
That sounds like question number 6. What was the question? Is there a question before that?
Yes, there was. How many grams of AgNO3 do I need to make 100 grams of silver?
There you go.
How many grams
Why do you say do I instead of do you?
of AgNO3 do I need?
Is it you?
Do I need to
You're supposed to read
make how many grams of silver?
100 grams.
100 grams of Ag.
That's correct.
Alright. Wow, okay, so what's different about this question? This question is, you've been given the amount of product you want, and I want you to tell me how much reactant I need.
Do it in reverse.
Before, every other one has been, I've given you reactants, tell me how much product I can make. It's the same exact thing. It's going to be a moldable ratio, and you think I'd like to say you're working in reverse, but really not working in reverse. You're just using what you've been given. You've been given 100 grams of silver, right? So let's plug 100 grams of Ag in there, and we're just going to convert this Ag into AgNO3, right? So it's essentially what we're doing is we're just like doing this, right? We're just drawing the arrow backwards, and you can say, okay, this is going to be our reactants now, and this is going to be our products. How much of this do I need to make that, right? Same exact thing, only going sort of backwards. So we have 100 grams of silver. We need to get our molar masses here. What's the molar mass of iron? 55.85. Very good. Grams per mole. What's our molar mass of AgNO3?
161.91.
Whoa. Uh-oh. I hope I'm not wrong. I have 197.43.
You should be right.
Anyone else get that?
I
Yeah.
got what
You got what?
I got what Anna got.
Uh-oh.
Okay, anyway, got a calculator? Ag 107.8. 107.8 plus nitrogen, which is 14, plus 16 times 3. What do we got? You look like you're doing it.
Well, let's
I
do
was
the last
All
one.
right, it's 107
Just the last one.
16 times 3, plus 16 times 3. 169.8, Benjamin. I thought you were checking these
Well,
for
maybe
me.
you should check it too.
I get it. I
you
should
got
have
that
to check it
answer,
and do it.
We both got the exact same answer, Dad.
Oh, that's awesome. Okay, what was it?
wrong. Or
Point.
it's 9-1.
Yeah.
0.43? Wait.
9-1, yeah.
I still don't believe I'm wrong. Let me see here. Because that just looks like really small. We're starting out. We are starting at. Oh, I see what it is. No, I'm right.
I knew it.
Phew! Oh, man. That was a close one. Okay. 197.43. Look at this. It's iron. Wait. Yeah, no, okay, I'm sorry. We're here. Oh, no, you're right. No, it is AgNO3, isn't it? AgNO3. Shoot, I'm wrong.
I think we got that on video. Nobody edit that out. Please don't.
Basic arithmetic. What was it again?
What are
69.91.
It's all my numbers. Oh, wait, what's FeNO3 2? I didn't even add that up. Oh, we don't need it for this. We don't even need it for this. What's Ag? Ag is 107.9.
Yeah.
All right, so 100 grams of Ag is is 107.9 grams of Ag per 1 mole of Ag. Right? Now we got 1 mole. Oh!
Wait,
What
we
did
forgot
we
to
do?
balance it.
We forgot to balance it. What do we need to balance it?
A 2,
A 2
another 2.
and another 2. Right? All balanced. All right, so we got 1 mole of Ag. Actually, 2 moles of Ag. 2 moles. 2 moles of Ag. Yep, 2 moles of Ag is equal to 2 moles of AgNO3.
215.8.
AgNO3. And then we go 1 mole of AgNO3 is equal to how many grams of AgNO3? 169.91. Oh, wait, no, look, I got it. Look, I got it right. Okay, I got it right. Man. Oh, actually, BB crossed it out and put it right. Did you put that in there, Dave?
Yeah, that was me.
I just didn't cross it out there. Okay. All right, and that gives us 157.5 grams of AgNO3. All right, so that's how much AgNO3 I need in order to make 100 grams of Ag. And what was the next question?
How many grams of Fe will need to react with that amount of AgNO3 to make that amount of silver?
Okay. So we want that amount of silver. So what they're asking is 100 grams of silver. How much Fe do I need? Exact same problem. Right? So we're going to start out with 100 grams of Ag. 100 grams of Ag. 107.9 grams of Ag equals 1 mole of Ag. Stop me if you've seen this before. 2 grams, 2 moles of Ag is equal to 1 mole of Fe, right? And then 1 mole, man, this stuff is so fun and easy. 1 mole of Fe is equal to 55.85 grams of Fe, which gives us 25.9 grams of Fe.
How do you get
Ta-da.
that number? Like,
Yeah.
how do you multiply or
You multiply the top and divide it by the bottom.
Yeah, you can do it 1 or 2 ways. You can do 100 times 1 times 1 times 55.85 divided by parentheses all this. 107.9 times 2 times 1. But you gotta, when you plug it into your calculator, you gotta make sure that you do parentheses around this or push the divide every single time. So if you go 100 times 1 times 1 times 55.85 divided by 107.9 divided by 2 divided by 1.
So when you say 1 mole of Ag, where do you get, that's where I'm going to be, where are the moles?
It's
This, your mole to mole ratio? Your mole to mole ratio is dependent upon your balanced equation. right? 2 moles of Ag,
Is that
2 moles of Ag is equal to 1 mole of Fe in this balanced equation.
How though?
Because it's a balanced equation.
what is that number right here all the way to the right? Top. Nope, up. Down. Down. There, wait, right.
55.85. That is the molar mass of iron. And we pull that number from our periodic table for iron. Iron, 55.84.
I did actually last one.
That's what I think.
Did you get it? Okay, calculator, ready? Go 100 times 1 times 1
Okay.
times 55.85 divided by 107.9 divided by 2.
Do I press equal?
You can.
Or you just
That's the safest way. Divided by 2 divided by 1, 25.9.
I divide the whole top and the whole bottom.
That's fine. As long as you do
like
parentheses.
multiply both of them and then divide by the number that I got.
That is way too complex.
So
No,
you,
it's so
you
much
figure
easier.
out the numerator, you figure out the denominator.
I just divide by one.
Yeah, you got to make sure when you do that that you use parentheses so that the calculator knows what you're trying to do.
That takes way longer.
It's good, doesn't it?
That way.
You good, Grace?
It's less confusing though.
If you have a calculator that has boxes in it, it's easy.
Well, I don't use for this.
Yes, Taylor?
What I did for number 6, I just took I was confused with, to react with that amount of Ag in a food.
Yeah, I was kind of being coy. Yeah, I didn't give you the number.
157.5, and then started from there and went to Fe.
That would convert. That's interesting. That will. Would that work? Did that? You get the same number? I think
I
you
got
should.
25.88 down.
Yeah, you got the same number. Yeah. Yeah.
Mom, can you take it down?
Good? Clear as mud? Can you erase?
Mine's not clear, so I'm still very.
That's the fun.
Just
Alexander.
Because clarity comes now with pain. So, you know, if you want it more clear, you got pain.
In all of the creatures, everyone died of academia or something. It's so actually.
But it all starts with what?
Straightness, clarify.
A balanced equation. Gotta be a balanced equation.
That's actually.
No balanced equation, no mole-to-mole ratio. Any further questions? Before we blaze through empirical and molecular formula? We're doing fun stuff today in chemistry. That's redundant. We do. Do it? No, right after today. Till next week.
Yay!
Yeah. That's like
Yeah.
6 to 8. That's awesome. No, we'll get a Christmas break. We had the flood. The flood took all of our.
Are we gonna get a 3-week Christmas break?
You get a 1 extra day.
Yeah, that's fun. Yeah, God bless you. Molecular formula. What's
Please
molecular
tell me
formula?
it's just not.
What?
Is it more than 1 week? Is it 2 weeks?
No, it's like a day. You really think he's gonna give us 2 weeks?
I think I'm gonna be sick.
I'm gonna be out of state. So.
Molecular formula. What did we say molecular formula was?
Shows the exact number of atoms.
All of that.
Exactly good. Shows the exact number of atoms.
Come on, guys. You should write it once.
Real. Such a thing all this.
Pardon me. Atoms
Sure the trash can line
in
said.
the molecule. Molecule. Molecule.
Just spell it how it sounds.
Molecule. Molecule.
I'm changing the way it sounds. So.
We'll pronounce it how it sounds. You know.
How about empirical formula? Oh shit, I can't spell empirical formula. Empirical formula. What's that? Shows the ratio of atoms in the compound. Shows, actually it's the lowest ratio too. Shows the
No, probably not.
C6, H12O6. Empirical formula would be C1, H2O2, O1. Right? Now, today, what we're going to learn is some busy work. That's going to keep you off the streets.
Didn't we learn this last week?
No.
No, we were supposed to though.
Mhm.
I think we went over it's like.
You have three basic problems in empirical formula land. Everyone get this, Julia? Empirical formula land. And we're going to go up to date.
There's a video, no.
We're going to go over each type of problem. So, number one, problems based on empirical. That's not how we spell empirical. Empirical/molecular formulas.
We're throwing each other to do something.
First one. Given percent makeup of a compound, find its empirical formula. Actually, there's another kind of question too, but that's even easier.
Sure, why don't you give us that one first?
No,
Percent. Well, we already did that one. Given percent makeup of a compound, find its empirical formula. Okay, what this looks like is the following. The percent composition of an unknown compound was found to be 63.5% silver, 8.2% nitrogen, and 28.3% oxygen. Find its empirical formula.
We seriously, what are they?
We are.
Wait, we're only a quarter of the way through. Are you kidding me? Dang. Wait, we're about to finish the
We
semester.
just started.
Wait, we're about to
We
finish
just
the
no,
semester.
no.
Yeah, we started in July,
We
remember?
started while
Wait,
we're really
what
slow.
the heck?
We're really slow then. Okay,
We're gonna
so
be like going all the way through summer.
Yep.
what we want to do, steps.
Yeah.
Steps. Number one,
It's
assume
like Latin all over again.
That was the worst summer.
100 grams of the unknown compound. What does that do for us?
Means we got stuff.
If we assume 100 grams of the compound,
Makes it easier.
it does make it easier. Makes it a lot easier. What does that do for our percentages? If we assume 100 grams, that means our percentages become weights. Right? Oh yeah. So all our percentages become weights. So now we have 63.5 grams of Ag. We have 8.2 grams of nitrogen. And we have 28.3 grams of oxygen. NOY and OZ, right? We know there's going to be some amount of that. We don't know what though.
So X, Y, Z are your missing variables.
Yes.
What?
So excited for this test. I mean, you just read it all over my
Oh, it's gonna be a blast.
3/4 left, guys. That's it.
Let's see. Let me think about the rest. The rest of the quarters, really, it gets easy. This is really the meat and potatoes here. We go on. We talk about P and S, and D orbitals. That's easy stuff. We do get into thermodynamics. Thermodynamics is a little bit hairy. Buckle your seatbelts for that.
a car.
The windows don't hold up.
Okay. So, can I erase this?
Wait, because that's right. No.
Yes, these become weights. All right, so now we got 63.5 grams of Ag, 8.2 grams of nitrogen, 28.3 grams of oxygen. Then we get acid base equilibriums. Okay, that's a little hairy.
Wait a second.
So this is
Okay, really, this is easy stuff we're gonna do later.
Those are the same number. Yeah.
Exactly. No, they're not. They're percent grams. Because we assumed 100 grams of the compound, we are able to convert all our percents into masses.
Okay, cool. So weights just means grams.
Yeah, right.
What does that say? Became weights.
Mass. I suppose that should say. Mass would be a proper terminology we use there.
Just go over English. You cut out most words.
Good. Can I erase?
Yes.
Not yet.
So yes.
So what was the definition for empirical formula again? Off the top of that.
They give it gives ratios, lowest common ratios of
The
the
lowest
atoms.
ratio of atoms.
We good? Ding.
It uses lowest ratio.
Katrina, you
Just
ready?
take a picture.
Oh, I'm on empirical formula. Like I mentioned, I already know all that.
Wait, where's the thing?
You started.
I don't know. I'm rolling. All right. I'm going to keep my masses down there just so we know what we're talking about. All right. So the second thing we're going to do now, so the second thing,
Like 5 minutes ago.
use masses
Okay, Alexander, seriously.
to determine
Can't read it.
moles of each
What's this here?
atom. Okay? So, use masses to determine moles of each atom. Oh, well, that's a piece of cake. That's what we've been doing all along. I can do that in my sleep, Mr. Mike. 63.5 grams of Ag. We need to convert this to moles. What are we going to do?
Conversion.
Yeah.
I thought we were done with moles.
Molar mass, we need to convert to moles. So how are we going to do it?
Okay, this thing.
107 grams Ag, under 1 mole.
Excellent. And that's going to give us, I don't know, 0.589 moles.
Wait, we're 907.9 grams. Oh, okay.
Understanding is going to come with pain. 107.9. Right? That's what we've been doing for the past 3 weeks. 3 weeks.
I keep forgetting to go back to that.
It's in here too, Alexander.
Yeah, I
It's
know.
not like it's hidden secret research.
All right. How about grams of nitrogen? What do we got? 8.2 grams of N2, or no, just nitrogen actually. No, not N2. Nitrogen is going to be, what's the molar mass of nitrogen?
14.007.
Wow, really? 07 grams, okay, equals 1 mole of nitrogen.
Yes.
And that's going to give us 0.589 moles of nitrogen. Moles of Ag. say that yet. I'm gonna wait. What's our molar mass of oxygen?
16.
Grams. Oxygen equals 1 mole of oxygen. Whoops, I didn't mean that. And that's going to equal 1.77 moles of oxygen. So, now we have moles. Moles, moles, moles.
Are you done, Rosie, yet?
No.
Please.
Mercy.
Yeah.
Just draw over there on the side.
Alright, I can try that. Step 3.
Okay, now you're good.
No.
Oh, it's already.
I missed on the first part. Oh my gosh. There's a video. Just keep No. I want apples. 8 point.
On the first one.
Done. I want the first one.
Or the third one.
Last 8. Is that 8.2?
Where?
That's 8.2 grams of nitrogen. Grace, you right there, really?
Yeah.
Divide through by lowest mole. That's kind of hokey. I want to say that really.
Too many words.
You can never have too many notes. Okay, so what does this mean? Our lowest mole, our smallest. Okay, I'm gonna put smallest too. Just I don't know. Proper English. I don't know. So our lowest is 0.589, right? So we're going to go through and we're going to divide each of these by 0.589. So at 0.589 moles of Ag, 0.589 moles of nitrogen, and 0.177 moles of oxygen. All right, so we're going to divide.
That is 1.77.
Thank you, 1.77. We're going to divide through by 0.589. What does that give us here? 1 mole. What does that give us here? Whoops, let me divide through by 0.589. It gives us 1. Divide through by 0.589 gives us 3. This is just giving us a whole number. Right? The magic of math. You can do anything to whatever as long as you do it to everybody, right? Like that. Sound like a Democrat. You can manipulate both sides of the equation however you want as long as you do it the same way to both sides. Right? So basically all I'm doing is turning these into whole numbers. So now we have 1 mole of Ag1. We have 1 mole of N, 1, and we got 3 moles of oxygen. And that becomes our empirical formula. AgNO3. It actually happens to be our molecular formula too.
And this is busy work?
Yeah, it's to keep you from breaking into people's cars. Stealing their tape decks and stuff like that.
Right. What if it's like a hobby?
Yeah.
I mean, you're talking about like Alexander.
What happens
Okay, I've broken the houses, guys.
I thought more than that.
Oh, I haven't.
This kind of garbage. I don't. If any of you plan on trying to cut out of chemistry in college, this is the kind of garbage they throw at you. Busy work, being able to do this kind of
I'm
stuff.
gonna go to a profession where you don't have to.
This is what the teachers give you
You're
when
gonna be
they
a
want to text
professional?
for an hour.
A professional what? Yeah.
Professional non-chemist.
Yeah,
I was
that's
a professional chemist. I didn't know this stuff. All right. So you want to try one on your own?
No.
Oh yeah.
Shut up.
What's your problem?
Quiet.
Now what I could have done too. Well, no, you'll see that. You'll see that.
Perfectionist yourself.
I know we kill it.
Sharing is not caring.
Is there a copy?
I smell it too. I think it's
Sharing is,
Okay.
probably the opposite. Sharing the flu. Yeah. Sharing is.
I know it's
Okay. Blah 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 blah. The compound's 89.14% AU and 10.8% oxygen. What is it? What's its empirical formula? You had to give my answer for this. Oh well. I know, actually, hold on. Let's do it. Oh, that's fine. Go ahead and do that. 89.4 AU and 10.8% oxygen. What's its empirical formula?
I think I'm starting to get this whole multiple ratio. Like, this is easy, but it's all multiple.